Good morning, everyone. Welcome to Science 101. My name is Kate Rachel A. Kimpo from STEM 11 Cards. For today's lesson, I will discuss about Dalton's law of partial pressure and Graham's law of diffusion. So, if you are ready, let's get started. First, let us know about Dalton's law of partial pressure. John Dalton is an English chemist and discovered the law in 1803 by observing the behavior of gases. According to him, partial pressure is the pressure of each gas in a mixture. It is also the pressure that gas would exert if it were by itself in the container. So as long as the gases are non-reactant, they can be added to get the total pressure. So Dalton's law of partial pressure states that the total pressure exerted by gases in a mixture is the sum of partial pressure of those gases. And we can derive the formula P2 equals P1 plus P2 plus P3 and so on, wherein P1 is the pressure of the first gas, P2 is the pressure of the second gas, P3 is the pressure of the third gas, and P total is the total pressure of all gases. In this picture, you will observe that container has two gases. These are elements helium and argon. The pressure of helium is 2 atmosphere and the pressure of argon is 4 atmosphere. To get the total pressure, we need to add the pressure of two gases, so that's 2 atmosphere plus 4 atmosphere equals 6 atmosphere. So the total pressure of gases in the container is 6 atmosphere. Let us have a sample problem involving Dalton's law of partial pressure. For example, a container holds three gases, oxygen, carbon dioxide, and helium. The partial pressure of the three gases are 2 atmosphere, 3 atmosphere, and 4 atmosphere, respectively. What is the total pressure inside the container? To solve this problem, first, we must know the given. So we have the pressure of oxygen is 2 atmosphere, the pressure of carbon dioxide is 3 atmosphere, and the pressure of helium is 4 atmosphere. Using the formula of Dalton's law of partial pressure, we have the total pressure equals pressure of oxygen plus pressure of carbon dioxide plus pressure of helium. So that's 2 plus 3 plus 4. So the total pressure of the container is 9 atmosphere. Now, let us apply the law of partial pressure in real life. When a scuba diver dives, the increased pressure causes nitrogen gas to dissolve in the blood. If a diver rises too fast, the dissolved nitrogen will form bubbles in the blood, will be dangerous. Helium, which does not dissolve in the blood, is mixed with oxygen to prepare breathing mixtures for deep descents. For example, a scuba tank contains oxygen with a pressure of 0.450 atmosphere and helium at 855 millimeter mercury. What is the total pressure in millimeter mercury in the tank? To solve this problem, first, we must know the given. The given are 0.450 atmosphere and 855 millimeter mercury. Since we have different units of pressure, we need to convert the pressure in atmosphere to millimeter mercury. One atom is equal to 760 millimeter mercury, so 0.450 atmosphere of oxygen multiplied by 760 is equal to 342 millimeter mercury of oxygen gas. The next step is now to calculate the sum of the partial pressure, so that 342 millimeter mercury plus 855 millimeter mercury is equal to 1197 millimeter mercury. So the total pressure of gases in the scuba tank is 1197 millimeter mercury. Partial pressure can also be applied to the circulation of gases in our blood. In the lungs, oxygen enters the blood while carbon dioxide is released. In the tissues, oxygen enters the cells, which release carbon dioxide into the blood. Here are the information about the partial pressure of oxygen and carbon dioxide in our blood and tissues. Now that you understand Dalton's law of partial pressure, let us now proceed to Graham's law of diffusion. Graham's law of diffusion was discovered by Thomas Graham, a Scottish chemist, and discovered the law in 1848. Before we go the law of diffusion, let us differentiate between diffusion and effusion. Diffusion is the process which by gas particles spreads out. Examples of it are the scent of perfume in the room and the smell of food in the kitchen. Effusion is the process by which gas particles escape through a tiny hole such as the loss of gas in the balloon and slowly escaping of air in a tire pinhole. Diffusion and diffusion are related another since we are talking about the rate of which gas particle moves. Graham's law of diffusion states that under similar conditions of temperature and pressure, the rates of diffusion of gases are inversely proportional to the square root of their densities. Graham's law of diffusion is important in separation of gases having different densities, separation of isotopes of certain elements, and to determine the density or the molecular mass of an unknown gas by comparing its rate of diffusion with a known gas. The formula that we are going to use to identify the rate of diffusion or effusion of gas particles is rate A over rate B is equal to square root of mmB over MMA, wherein rate A is the rate of which gas A moves, rate B is the rate of which gas B moves, MMA is the molar mass or weight of a gas A, and mmB is the molar mass or weight of a gas B. Here is a sample problem of Graham's law of diffusion. Let us compare the rate of effusion between hydrogen and oxygen gas. What are we going to do is to identify the molar mass of the given elements. If we look at the periodic table, the mass of hydrogen is 1, but since hydrogen is a diatomic element, its molar mass is 2 grams per mole. Oxygen has mass of 16, but oxygen is also a diatomic element. Its molar mass is 32 grams per mole. Using the formula, we have rate of hydrogen over rate of oxygen is equal to the square root of 32 grams per mole over 2 grams per mole. Take note that on choosing gas A and gas B, we must know which gas is lighter and heavier. Hydrogen is lighter than oxygen, so hydrogen is a gas A. It is lighter than oxygen or gas B. So 32 grams per mole over 2 grams per mole is equal to 16 and the square root of 16 is 4. It means the hydrogen gas effuses 4 times faster than the oxygen gas. Let us have another example of law of diffusion, but this time we need to identify the name of gas. If methane effuses at 1.414 times the rate of unknown gas, what is the identity of the gas? To solve this problem, we must first know the given. The only given is in the problem is methane and effuses at 1.414 times. Since methane is lighter compared to the unknown gas, it will be our gas A and the unknown gas is gas B. Since methane is the given gas, we need to get its molar mass. The chemical formula of methane is CH4, the mass of carbon is 12, and the mass of hydrogen is 1 multiplied by 4 is 4. So the total molar mass of the methane is 12 plus 4 equals to 16 grams per mole. Using the formula, we now have 1.414 over 1 is equal to the square root of molar mass of B over 16. The next step is to transfer the square root of to the other side, so it will be 1.414 over 1 squared. 1.414 over 1 squared is 1.999. 1.999 multiplied by 16 is 31.98. So the molar mass of the unknown gas B is 31.98. If we look at the periodic table, the, the element with a molar mass of 31.98 is oxygen. So the entity of the unknown gas is oxygen. I hope that you learned our lesson about Dalton's law of partial pressure and Graham's law of diffusion. In summary, Dalton's law of partial pressure states that the total pressure exerted by gases in a mixture is the sum of the partial pressure of those gases. And Graham's law of diffusion states that under similar condition of temperature and pressure, the rate of diffusion of gases is inversely proportional to the square root of their densities. Thank you for listening and God bless.